And we have a one-page summary of overall status that involve all lake trout biologists built on the all source of data or lake trout. And I saw that copy on Oregon, so if you are interested or contact Steven and me, then we can send you a digital copy. Here I just try to take that broad view and emphasize the analysis of the spring survey. The objective is from the change in size structure to understand the major factor that influence lake trout abundance. The major factor, of course, recruitment, mortality, and individual growth. Sometimes we emphasize size regulation, hope to achieve a certain size structure. Sometimes we more emphasize population dynamics, but the basic factors are those three. We hope, given a status of the ecosystem, to achieve some balance about those three factors. But recent years, the ecosystem continue to change over time. We still hope to achieve the best balance. And here I just show the very familiar 4-inch size increment of size group. I regroup those to juvenile, young adult, and old adult, 3 size group. Here, the left panel shows where more than 30 years ago Randy started the time series, and the right panel is the size structure and the well and the hatchery composition we have seen from last year's spring survey. So I will try to understand where we go from the left to achieve the recent observation in 2014. This slide shows up to mid-80s, you can see the population was dominated by juvenile fish. Hard to see a young adult at all. That indicate a mortality is too high. Fishery mortality, sea lion pay introduced mortality. About at beginning of 1990s, show somehow good sign the young adult start to dominate the spring catch, but no very long go back to the status juvenile fish dominate the catch. By the end of 1990s, beginning of 2000, you can see the sense start to change and then get the young adult dominant the catch. It's about that time we see alewife crabs, natural reproduction start, lake-wide natural reproduction. So that's indicate the point is the build up the spawning stock, get ready when alewife crab, then natural reproduction could happen. Another point is here, even the young adult dominant the catch, the recruitment still about the juvenile still contribute about 10 to 30% of the total catch. And that's the most recent picture. The major concern all agencies, all biologists, is about the recruitment. Yes, we see a lot mature, large, old lake trout. We start to see the natural reproduction, but the concern was that the recruitment. So that's the observation from last year's survey. Any complaint about this size structure? Hardly. Only a hope is we just hope take time the gradually wild fish replace the hatchery fish. This is just from another angle to see the same thing. Each panel I run several years data, and some information got lost, but to save time, I just say by the end of 1990s, we can still see the structure is a truncated, a high mortality. But things getting better. Take a few years rapid expansion of the age structure. If natural mortality is too high, if total mortality too high, that can rapid expansion of age structure is impossible. You can see that's age 4. It's hard to find age 4 fish anymore. And you can also see the peaks of the catch, age 5, age 6, age 7, age 8, indicate the juvenile growth is much slower than before. This is the age structure 2014. So it indicates low recruitment since 2002 year classes. And that timing is very important. And this kind of low recruitment in Lake Superior, we all know it's mostly related to the density effect. But in Lake Huron, 2002, we all know that's a food web change in 2003 alewife complete collapse. And following that, because we lost the predation buffer, the recruitment of hatchery fish just at least 8 consecutive years. But until the 2010 year class, a strong signal, mostly wild fish, but hatchery fish also recover to a certain degree. So this is CPE per recruit, that's per million or stocking or yearly. This kind of increase is because of decline of adult mortality. That's quite successful. This timing is related to match the size structural change just almost exactly. But recent year, the CPE per million stocking decline. This increase is because of decline in mortality, and this decline is because obviously decline in the recruitment. And this just say for the fish less than 21 inch, and this indicate we cannot fully rely on age structure talking about mortality and recruitment. Of course, if you have low recruitment, young adult may appear to be dominant in the catch. And this year, we recall that 2001 year classes and early year classes still support the fishery catch. So this, if this decline is true, it's impossible. We continue to see the age structure like this from fishery hatch, at least in Michigan water. Still, the fishery is supported by those old year classes. So I would say at that time, just build up a lot young, old, large lake trout. And meanwhile, it's a time the alewife and the rump smell substantially declined. The implication is that selectivity is not fully, as we traditionally talking about fish size and the measure size of a gillnet. It influences something else. If you caught a large old lake trout, it's hard to at the same spot to catch the young lake trout. So if we concern about the recent recruitment status, maybe better focus on this period. This is what we can see. That hatchery, after alewife collapse, the recruitment of hatchery fish decline, fly at the bottom. And well recruitment continue increase. Most recent year, at least give us an implication current natural recruitment is comparable about 1.5 million stocking of hatchery fish. Not exactly, but should be in that level. But previously, even lake-wide well recruitment have been reported for many years. Total amount the well fish may not be comparable if we're stocking 1.5 yearling every year. But recent year may be in that level. So this slide just shows the increase of the 21-inch, less than 21-inch fish or wild fish, shows kind of a 5 year, then go to another level, and this jump to another level. Whether or not it's another high level or just a 1 year event, let's wait to see next year's survey. But from this year, here I show the spring survey finding. But from commercial fishery from Ontario side, from commercial fishery in northern Lake Huron, from the summer survey conducted by Fish and Wildlife Service and Cora, this year's similar signal is there. Now, how do we explain this kind of stepwise increase? One possibility is wild fish is more effective than hatchery fish. Then you have that kind of at least a 5 year, then go to another level, then go to another level. So this shows the fish larger than 21-inch CPE. Then of course, this is because of a decline in adult mortality. Recent concern, we observed at least 8 consecutive year low recruitment. Then the decline with the adult CPE is the same. Do we have a concern in the future? If recall the previous slides, we do hope the wild fish will increase and continue to support the population abundance. This it's good to follow Stephen's talk about the fishery migration sense. This slide shows the size structure, northern Lake Huron, north central, and the southern. The structure and the well and the hatchery composition was very similar in southern Lake Huron or the lake-wide pattern, but here north and north central looks so dramatically different. Can we explain that? I would try to dig out why. I would say maybe we should keep simple, combine those 2 units. Otherwise, it's hard to explain what happened here. But once that do indicate Drama Island, maybe an offshore reef, that's a strong source of the recent natural recruitment. What I did not show is Ontario side. They detect the well recruitment at least 3 years earlier than US side. And right now, the well percentage should be about 80% now. It also makes sense. About 80% hatchery fish stocked in the US water. If this is a strong source of recent well recruitment, then we can see Ontario side will, from both fishery and fishery independent survey to see much higher well percentage. So the taking home message is no recovery over age 7 CPUE per million stocking. We see some signal increase over age 3, age 5 CPE hatchery fish. It's hard to believe it will recover to previous level. And no real concern about the recent trend on natural recruitment. And what we do need to remember is a shift of the major factor that influence fish lake trout abundance. Previous year, the concern we have a relatively stable recruitment from hatchery stocking. Only concern is adult mortality. As long as we can keep the mortality low enough below the limit, everything should be fine. But we observed 8 consecutive year low recruitment. But since 2010 year classes, that recruitment level may be increased to very high level. But let's wait to see if that recruitment productivity and recruitment increase. And that's from yesterday's talk, Lake Superior talk, several talk indicated the mortality is below the limit, but population going down. That's a similar concern about here, the recruitment part. If recruitment always have annual variation over time, but over year average is a relatively high level. In comparison, about 8 year or 10 year relatively low over year average of recruitment. That's something need to consider. So the implication is current harvest policy is we coded our best understanding into the long-term harvest policy, and we do annual assessment, annual update our stock assessment model, adjust our understanding about the population status, then take management action. That's a fishery regulation. But the things continue change over time. So maybe another strategy is keep the fishery regulation relatively stable, allow us to learn from the fishery, from fishery independent survey, but periodically review the stock assessment along with the harvest strategy. So that's all.